Hi class, I would like to begin our lesson today by telling you that the student of the day today is Sarita, because I think that our joke of the day is worthy of Sarita. Okay, I'll tell it to you later. So what if you had an equation that was in standard form and you wanted to know the vertex of it? So you really have two options. You can do what we did in the beginning when we were doing the Davy. You could use negative b over 2a to find the x value and then plug it in to find the y value. Sometimes that's more convenient. The other way is what we're going to be learning today, is you could transform the equation from standard form into vertex form by completing the square. Your favorite thing, right? So here's a little example. So you have a basic equation here in standard form, meaning that you can't just look at it and see what the vertex is. So we're just going to find the vertex in two ways. The first way is to do negative b over 2a to find the x value of the vertex. So negative b is 4 over 2 times a is 2. So here we know that the x value of the vertex is 2. Now I have to plug 2 into the equation to find the y value. So I get 2 squared minus 4 times 2 plus 1, that's 4, minus 8 is negative 4, plus 1 is negative 3. Now let's try the other option. So hopefully you remember completing the square. I know it's been a while. It just looks a little bit different here because we're not trying to solve an equation. We're actually just trying to figure out a way to write this as something squared. So in order to do that, we do most of the same things. We take half of b and we square it, and we're going to add that in. But now we want to keep everything on one side of the equation because we don't want to mess with the y. So we are going to do something to make it so that that 4 didn't change it. So if I added 4 to this side of the equation, I want to do something so that it undoes that adding 4. And that is subtracting 4. Here, if I add 4 and subtract 4, I still really have the same original equation. I know that you're used to adding 4 on both sides, but think of it this way. If I didn't subtract this 4, it confused you. If I added 4 to both sides instead, then I would just have to subtract that 4 to get rid of it so that y would be alone to graph it. And that's really all we're doing. So now here, we just have to rewrite this as something squared. Try to factor just this portion of it. So in order to do that, it's always just like it used to be when we were completing the square. It's always x in that number. So it's x minus 2 squared plus 1 minus 4 is just negative 3. And now you can easily see that the vertex of this is 2, negative 3. Either way, you get the point 2, negative 3 as your vertex. I guess I do care how you do it. We're going to be practicing option 2 today. You already know how to do option 1. So you just have to use completing the square. Now you have to plug in any other point. I don't care what that point is, you just try to pick something that's convenient. If you want to plug in 0, that would be a nice, easy one to plug in here. If I plug 0 into this equation, I just get 1. So I know I have the point 0, 1 in addition to the vertex. So 0, 1 is here, then reflect that point over the axis of symmetry, and I have my parabola. Let's try another example. So here's another example that you're not going to like because we're going to have fractions, but that's life. All right, so here I'm going to take this number. I'm going to leave that. I'm going to leave a space here so I can add that special number in. I take half of this term, which is not a whole number, it's a fraction. That's okay though, don't lose your minds over it. And then we're going to square the top and square the bottom, and we're going to add that here. We are also going to subtract that so that the original equation stays equal. Now we're going to try to rewrite this as something squared. So if I write this as something squared, it's always x and this number. So x plus 3 over 2. Now I have to try to simplify these two quantities together. So 2, if you want to find a common denominator of 4, you have to multiply this by 4 over 4. So I get negative 8 over 4 minus 9 over 4 is negative 17 over 4. So now here, it's not pretty, but our vertex is just the opposite of this number, which is negative 3 over 2, and then this number, which is negative 17 over 4. So I realize that this may be a little bit difficult for you to know where to graph these when they're written as improper fractions. So if you want to write them as decimals, write them as decimals. That's fine. So this is negative 1.5, and 17 divided by 4. 4 goes into 17 4 times with 1 left over. So it's negative 4.25. So you can just go to negative 1.5, negative 4, 1, 2, 3, 4, and a little bit. So that's our vertex. And now plug in any other point. It doesn't matter what you plug in. Let's plug in 0 in standard form. If I plug 0 into this equation, I just get negative 2. So I have point 0, negative 2. And now make sure that you reflect that over the axis of symmetry, which is going to be here. And that's my parabola. Okay, so here is our joke. One Sunday morning, a little girl and her mother go to church. Halfway through, the little girl tells her mom that she's going to be sick. Her mother tells her to go into the bushes behind the church to throw up. The girl leaves and comes back after 5 minutes. Her mother asks her if she threw up. Yes, the little girl says, but I didn't have to go all the way in the back of the church. There's a box right near the front that says, for the sick. Sounds better, right? Okay, so here is another equation. This one's a little bit annoying because there's a 3 in front of the x squared. So before you do anything, you have to factor this 3 out. Oops, I'm getting ahead of myself. You're going to have to factor that 3 out. So I left the x squared plus 2x, and then this minus 5. I don't want to factor the 3 out of that minus 5 because it doesn't go in nicely, and it's really not part of what I'm trying to complete the square with. Just leave that negative 5 on the outside. Now I'm just completing the square with what I have in parentheses. I'm just worried about this little part of it here. So let's just try to complete the square with that. So if I do that, I'm still doing that same process where I take half of this number, which would be 1, I square it, still 1, and that's what I would add and subtract on this side of the equation. But you have to be a little bit careful here. You did add 1 on the inside of the parentheses, but if you distributed that 3 through, you're really adding a 3. So I have to subtract 3 to keep it equivalent to my original equation. If you don't believe me, let's just do it out real quick to make sure that you understand. So if I put that 3 through, I get 3x squared plus 6x plus 3 minus 5. If I simplify all these together, I end up with the original equation that I had. I'm just trying to, this minus 3, the only purpose of it is just to make the equation what it originally was. So now I have to rewrite this. Instead of this whole highlighted thing, I'm rewriting it as something squared. Just like before, it's always x and this number. So x plus 1 squared. I just combine these two now to be negative 8. So I have the vertex of the opposite of the number in the parentheses, negative 1, negative 8. So I go to negative 1, down 8. That's my vertex. Now I can plug in any other point that you want. I think I'm going to plug in 1. So if I plug 1 into this equation, I get 3 times 1 squared plus 6 times 1 minus 5. 3 plus 6 minus 5 is 4. So I have the point 1, 4. So now if you reflect that over the axis of symmetry, it comes out over here. You can see that this is a very skinny parabola. It's a very skinny parabola because this 3 out in the front of this has a vertical stretch. Okay, so that's our lesson for today. Don't forget to answer the questions.